questions?
No.
Yes.
Whoops. Great beginning of my lecture.
Mira,
Video.
you can't erase it now. Which one? The one in my math notebook.
Alright, so guys, I need it totally quiet.
Gary, is today the third? Yeah.
Yes.
But is this for Meets class?
This is actually for both classes.
Oh, yay.
I realize that everybody is in my class too is a little rusty, so I think it's okay to do this. Now, we learned yesterday that if we did x to the m times x to the n, that would equal x to the m plus n, right?
Yeah.
And that was pretty easy, right? Everybody understands that, right?
Everybody
If you're multiplying same bases with exponents, you add the you keep the base and you add the exponents, right? Pretty straightforward. Now, that's interesting. When you multiply same bases, you add the exponents. What if you x to the m divide by x to the n? You would keep the same base. What would you think? What would you think? Minus. So you do m minus n. M minus n. Now, usually you won't see it written like this. Usually you'll see it written like this. X to the m divided by x to the n. In other words, it's a fraction. But every fraction is a
subtraction.
division problem,
Division
right?
problem.
Every fraction.
Makes so
Therefore-
much sense.
Therefore, x to the m over x to the n is the same base, x, m, and I think of this line right here as a humongous minus sign. So we got m minus n, right? Humongous minus sign, right? M minus n.
Oh, wait, also,
Right?
Mary, the division thing, there, it's kind of times the times symbol, and then in the middle there's the big line, the division line. No,
Gary.
that one. Yeah. See,
So
yeah.
if there's
Oh, yeah, right, good, exactly.
so is it true that multiplication adds up with addition versus and division goes with subtraction easily? Because I see those two collide very frequently in math.
Yeah. Say for multiplication and in addition versus
But it's like going
There-
up, it's gaining value while division
with
is
exponents,
losing
yeah,
value.
with exponents you will see that in
It's
particular.
the same thing with
So,
square root.
so let's try a few. Let's try a few. Let's say I gave you, all right, we'll do a few examples. Let's say I had x to the 10 over x to the 6. Okay? So write this down in your notes. Again, it's just going to be their same bases, so I'm going to write the base. And I'm going to do 10 minus 6. Right? And then that gives me x to the 4, right? And I'm done, right? Now, why does this work? Let's try this. Let's do this the long way. Thank God for the shortcut, but let's do it the long way just for a second. This would be the same as this. X times 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 x. Right? Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? That's what x to the 10 is. Right? And this is x to the 6. That's x times x times x times x times x times x. You guys agree with me? Does that make sense? All right. What is x over x?
It's that.
1, right? If you have the same thing, a fraction. So that can be crossed out as a 1. What is x over x? Oh, what is x over x?
1.
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 Oh! So what do I have left over?
4x.
X to the 4th.
Right.
Oh, that's interesting. So I'm really glad I know this shortcut. So that when I give you,
Problems like x to the 800.
yeah, when I give you a second problem, which is x to the 800 divided by x to the 400, what would be my answer? X to the 400, right? X, same basis, x to the 800 minus 400, which is x to the 400, right? So nice to know that shortcut. So I don't have to put x's over all the walls, right? Right? Okay, now, I just have to see, I know I have other things in there. All right. Fist of 5, do you get this rule? It's pretty easy, right? Now what if I gave you, I'm just do one more. Sure. Did I do one of those? Hang on one second, I just have to see what I put in. Okay, yeah, let's do one more. Let's say I gave you 3x to the 4th over 9x. Okay? So the first thing I do is I look at my 3 and my 9. That's a fraction. I could simplify, right? 3 goes into 3 how many times? Once? 3 goes into 9 how many times?
3 times.
3 times. So suddenly now I have this. I have 1/3. And now instead of writing my x up here, I could just put my x here. X to the 4 minus, and what's this? There's a hidden 1 right here, right? You see this? Where did Lucas go?
Lucas over there.
Yeah, so equal.
Oh,
because
great,
they
so you
cannot
can
it
see.
from over
Oh, yeah,
there.
yeah, good. I'm glad you know it, thank you. So equals, so 1/3 x to the 4 minus 1, which is 1/3 x to the 3, right? Now some people might say, oh, well that could actually go in the numerator, because if that's 1/3 times x cubed. So some people might write it like this, and that's totally fine. Other people might write it like this. X cubed goes in the numerator, and the 3 in the denominator. Because think about it, 1/3 times x cubed over 1 is, you multiply the numerators, you get x cubed. 1 times that is x cubed, right? And 3 times 1 is 3. So either one of those could be the correct answer. You could write it either way. Does that make sense?
Yeah.
Okay, so that's 1, 2, 3. Okay.
Wait.
Can I erase something?
No.
Can I erase 1 and 2?
Yeah.
Okay.
No, you cannot.
Yeah, you can.
No, okay, now you can.
No, you
can, but you don't want to.
Now you can.
No, you
Okay.
can't.
Okay.
Actually,
No,
not
you
yet.
can't,
Just let Oliver finish writing.
Okay, go ahead, Oliver.
Yes, I have, but I'm still writing.
2 minutes, Gary.
I know.
Beginning countdown.
What? How did you get me?
All right, there is another rule. There's another rule. You notice,
No.
you guys, all these rules, you guys, all these rules, all they are shortcuts. You already know how to do exponents, right? It's totally logical how to do exponents. You know that if an exponent is next to something, you multiply that something times itself the number of times the exponent sets, right? Everybody knows it. It's just that there are shortcuts that allow us to go faster, right? So if I gave you a problem like, well, let me just talk about the rule. The rule is this. Well, no, actually, let's use x. I like x. X to the m, y to the n, parenthesis, to the, what is my rule? How do I write this rule? Oh, wait, oh, yeah, okay, no, that's, well, yeah. I'm gonna redo this, sorry. X, y to the m power, okay?
Equals x to the m. Y
It
times y to the
equals,
m.
right. Really, it means like, if we had xy to the 5th power, right? It would mean this. It would mean xy times xy times xy times xy times xy, kind of a lot of work, which is x times x times x times x times x, which is x to the 5th, right? And y times y times y times y times y, which is y to the 5th, right? So look at this. If we used our rule here, would be, the rule is this. X, y to the m power is x to the m, y to the m. It's interesting. So look, does that work? X, y to the fifth, x to the fifth, y to the fifth. It worked. It worked, right? Now, that's one example.
40 seconds over time.
I'm going to do one more example, just because I want to be sure you guys can see this. 4x squared cubed. All right. Now notice, where did the 5 multiplied, look at this. I'm going to put a hidden 1 here. I'm going to write the hidden 1s here. See that? The 5 multiplied times the 1. And it multiplied times the 1. So that's where I got x to the 5, y to the 5. Now I've got what's the exponent on the 4?
Nothing. You're 1.
There's a hidden 1 exponent. So now all I'm doing is multiplying 3 times, remember parenthesis means multiply, 3 times 1. So that gives me 4 to the 3 times 1, which is 3. And then x to the 3
6.
times 2, x to the 6. Does that make sense?
Article,
See that?
Yes.
See that?
Yep.
So it wouldn't be 12?
No. We'll leave it like that. Oh well. No. Never, ever, 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 ever multiply base times exponent. That means 4 times 4 times 4. Right? Question.
It would be 64 at that, or do you want 6?
Wait a minute, Anna, what?
Do you want us to leave it like that, or do you want us to do 4?
I'm okay with leaving it like this. You don't have to figure out 4 times 4 times 4. It's okay. I kind of want you to, I want to see that you understand this, right? You get this process.
Alright, thank you,
Okay,
Gary.
so,
Thank you,
so here's
Gary.
the homework.
No, dang it.
Homework.
I know you get away.
Homework. I almost forgot, but Gideon reminded me.
Man, well, I don't check my email.
So, you just have a recording.
Oh, really? That's